I'm Anil Kumar sharing with you a challenge trigonometric equation question. It is from a test paper. The question is solve cos square x plus cos 4x equals to 0.2 where x is between 0 to pi by 2. Now to solve this question we are going to use the double angle formula, which is cos 2 theta is equals to 2 cos square theta minus 1. Using this formula, we can write it in the form of a quadratic equation and then we can solve it. Now, you can pause the video, solve the question and then look into my suggestion. That should help you to review this chapter on trigonometric equations solution. Let's begin by writing cos 4x in terms of cos 2x. So we'll have this equation as cos square x plus cos 4x could be written as 2 cos square 2x minus 1, right? So we'll write this as 2 times cos square 2x minus 1 using this formula equals to 0.2, right? Now we can again write cos square 2x as 2 cos square x minus 1. So we'll again apply the same formula, the double angle formula, right? So we have 2, I'm taking out 2 outside, and we have cos square, so we'll write this thing in square, and instead of cos 2x we will write 2 cos square x minus 1. You get the idea? Now minus 1 is outside, so minus 1. We'll bring this 0.2 also to the left side, so it minus 0.2 equals to 0. So that is how we can rearrange the equation. Now let us expand it. So we get cos square x plus 2 times, let's expand this square, we get 4 cos square x minus 4, rather 4x, square of this, right? Minus 4 cos square x. That means 2 times a and b plus 1, and minus 1 minus 0.2 gives me minus 1.2 equals to 0. Let's open this bracket now. So we get cos square x plus 4 times 2 is 8 cos to the power of 4x minus 8 cos square x plus 2 minus 1.2 equals to 0. Let's rearrange this. We can write this as cos 8 times cos to the power of 4x. Cos square x taken away from 8 will give us minus 8 cos square x, and 2 minus 1.8 will be 0.8 equals to 0. So that is a quadratic equation, but this time the quadratic equation is in cos square x. So from here we can write what cos square x is. So cos square x is equals to minus b, which is 7, plus minus square of this, which is 49, minus 4ac, that means 4 times 8 times 0.8, right, square root, divided by 2 times 8, which is 60. Right, so let us calculate this value using the calculator. So within the square root we have 49 minus 4 times 8 times 0.8, which is equals to 117.5. We can do square root of this. That gives us, let's write down the decimal value, 4.83735. That plus minus, so square root is 4.83735 divided by 16. Now in this, so there are two values for cos square x. So we get 7 plus 4.83735. So we can do 7 plus the answer equals to divided by 16 equals to. So when we add, we get one decimal value, which is 0.7398. So when we add, we get 0.7398. So when I use plus, I get 0.7398, and when I use minus, let me write down, I get 7 minus 4.83735 equals to, divided by 16 is equals to 0.135. 0.1351. Okay, so these are the values which I get for cos square x, correct? Now, so cos square x is known to us. What is cos x? So for cos x, we'll get square root of these values. So we get either square root of 0.7398 or we get square root of 0.1351, right? So that is for cos x. Now, since we are considering domain of 0 to pi by 2, so we will only consider the acute angles. We are considering the positive values. So let me find square root. So we already have one of the numbers inside. So say answer equals 2, and this gives us 0.3676, and that will give us, let us say, square root of 0.7398 equals to 0.8601. So now we can find what cos x is. So cos x is cos inverse of these values, right? Or cos inverse of 0.3676, right? So let's find cos inverse of this. So shift cos inverse of 0.8601, that is equals to 0.535. And let me find the cos inverse for the other number, which is shift cos inverse of 0.3676676 equals to, so we get 1.194. So that is the value of x which we get, and that is our solution, right? So we can write down our answer, that is x is equals to 0.535 or 1.194, correct? So that is how we can solve this equation. I hope that helps. Thank you and all the best.